Yes. So let's see. We have sorry. Let's see. We have a regular language. Okay. So we have something called as the acceptors. Called as the finite automata. We have already studied it. What we used to do, we give certain language and we draw the FA. For certain language, we used to draw the FA, and if it is reaches on to the final state, it used to accept the language. It means it should be considering all the strings possible. Okay, accepted. So Pine Automata, how many types we studied with output? What were those? Mealy machine and Murray machine. Okay, without output, what were those? DFA, DFA, NFA, and we were having epsilon NFA. We have studied this. Okay, so these are called as the acceptors. They were used to accept particular string for the language. Okay, now we have one more thing called as the generator. See, generator means this language will be generated by the particular grammar that is called as the regular grammar. Okay, these are also of two types: right linear grammar and left linear grammar. Okay, and then we have something called as a representator. Representator, what it basically does, it will be it will be doing the representation for certain language. Okay, it will be representing the certain language. What is what we call them? They are called as the regular expressions. Okay, so we have certain language and we'll draw a regular expression for it, so that by the help of regular expression itself we'll be able to find out what is the regular language uh, it is want to convey us. Okay, so that is why it is called as the representator. So let's start the regular expression. What is regular expression? Yeah, let's study. Okay, so we have basically three operations in our regular expression. Okay, what are those? First one is the union, that will also be denoted by plus sign. Okay, second one is concatenation, and we represent it by the help of dot, that is concatenation. Okay, and the third one is cleans closure, that is denoted by the star. Okay. See, by the help of these operations, we can derive any regular expression for any language. We'll see how we are going to do it. Okay, there are some of the basic regular expression. Let's check it. What are those? See, phi means what? Actually, phi itself is a regular expression, and it is regular expression for empty language. Language is present in the regular expression. This is the regular expression. Phi is a regular expression which is accepting nothing, empty language. For empty language, phi is a regular expression. Okay. Now we have one more thing called as the epsilon. Epsilon is also a regular expression. It is for what? The language corresponding to it is epsilon. Okay, so this is also a regular expression. Then we have see, when we used to draw the finite automata, we were having something called as the input alphabet. Okay, so whatever input alphabet is, it can also be present in the it is also present in the regular expression. So I'm writing a belong to, see, this is belong to, not epsilon. Okay, a belong to sigma. This is also regular expression. Okay, see, it means any input symbol from the input alphabet will also be present as a regular expression. Okay, now if I write a belong to sigma, it means the language present in it is a. For the language a, or for the string a, yeah, for the language a, the regular expression is simply a. Okay, if we take some more symbols from this input alphabet, then see, b can also be present in the sigma. So b is also a regular expression for the language b. Okay, don't worry, you will get everything once we used to draw the all the regulation. Just these are the basic terms. See, once we have the regular expression, we can perform all these we can perform all these three operations any number of time. Are you getting? See, we have these basic regular expressions, and to these basic regular expressions, any number of times, these three operations can be applied to show any of the language. Okay, we'll see how we are going to do it. It means for one regular expression, I can perform the union also, or I can do the concatenation also, or I can also do the cleans closure of it. Okay, and you can apply a and b any number of time, and you can get any of the regular expression for any of the language. You'll see some of the examples, and you will get to know how what I mean to say it, or what we are usually doing it, how we are doing it. So let's see. So here, suppose we write regular expression and language for which we are going to draw the regular expression. So for empty language, what regular expression we have? Phi. Okay. For epsilon to be accepted, we have regular expression epsilon. Suppose the language is A only. So what will be the regular expression? A, right? Now suppose the language is epsilon A, A, and so on. It means what it is saying. Any number of times A can come with and epsilon also. So the regular expression for it is A star. How I did it? See. Mm, It means when I put, see, in the place of a star, I can put 0, 1, 2, 3, 4, 5, 6, 7. Okay. So if I put 0, it becomes epsilon. See, it means the string of length 0 with the help of A, it becomes only epsilon. Okay. If I put 1 in place of a star, it means string of length 1 with the help of a, that is going to be a. It means string of length 2 with the help of a, it becomes a. Okay, if I write like this, it becomes a. Okay, so this is all the, this is what the language we want to accept it. Okay, so that is why I wrote, we can simply write as a star in regular expression. Okay, now we have something called as a plus. What it means, it means we are not gonna include epsilon. Without the help of epsilon, see, it becomes like this: a, a, and so on. Okay, so how it becomes, or we can simply say it as, mm, we have a star. Okay, it is including the epsilon. If I multiply it by 1a, it means when we put 0 here, okay, it, this whole will vanish, but this is still present here. It will concatenate with this and it is still present. See, a and epsilon becomes itself a. So minimum string here is small a. So it is not including the epsilon. So this is called as the a plus. Are you getting? See, what I am saying is a star means it is including epsilon also and so on. Okay, but if I multiply with one more a to a star, or we concatenate, no, we should not say multiply, I am concatenating. See, in the concatenate operation I can apply it. Okay, when we concatenate a with a star, it becomes, the language becomes, in it is a and so on. Epsilon is removed from here. How? See, earlier what we used to do, when we get the epsilon, when we put in place of star as 0, so it becomes string of length 0 with the help of a. Now this becomes void, or string with the help of 0, it becomes epsilon. Okay, now a concatenated with epsilon becomes a. Getting? Minimum possible string is already becomes a. That is why epsilon is removed from here or eliminated from here. Right? Likewise, we have, see, a union with b, and you put cleans closure of it. What it becomes? See, this means either a or b with any number of times. It become, it can accept anything. See, in place of star you put 0, a plus b, 0. What it will become? String of length 0 with the help of a and b. See, sigma here is a comma b, keep in mind. So it becomes epsilon. Okay, if I put in place of star, if I put 1, what will happen? String of length 1 with the help of a and b, it becomes, the language becomes a, sorry, a b. So this is the language. If I put a plus b power 2, what it says, it says with the help of a comma b, the number of see, yeah, it becomes string of length 2 with the help of a and b. It came like this: a b, b a, b b. So this is the string which is present in it. See, you can, for understanding purpose, you can understand like this. See, a is concatenated with a, Then A is concatenated with B, so it becomes A B. B is concatenated with A, and then B is concatenated with B. Okay, so this is the language which is present in A plus B power 2. Correct? On the same grounds, we can say that, so what will be the language present, or what are all the strings which will be present in A plus B whole star, or A plus B, yeah, star, cleans closure of A plus B. What are all the possible strings? See, epsilon is present here, A is present here, B is present. String of length 0, 1, 2, 3, 4, 5. See, okay, got it? A, B, B, A, B, B, A, A, B, A, B, A, and so on. Are you getting? So it means actually this includes set of all strings over A comma B. So language is infinite here. Okay. It means here simply set of all the strings possible with A comma B. Yeah, with the help of A comma B. Any combinations, any number of time. Star it denotes here including null. Null is also present here. Okay. So draw. Let's see some of the examples. Question number one. Let's say we have uh, sigma is A comma B. Okay. Now write set of you have to write regular expression for uh, set of all strings whose length is 2. Got it? So you have to write the regular expression for which is accepting, or regular expression for set of all string whose length is 2. So language is finite or infinite. So let's check what is the language will what will be the language for it, or strings A B B A, or what B B. Okay. So this is the language for this particular question. Uh, every string of length 2 with the help of input alphabet A comma B. Okay. Okay. So what you have to do? Just simply put union into it. A plus AB plus BA plus BB, because language is finite. So this is the regular expression for it. Okay. If you can simplify more, or it is not looking good, so what you can do, just pull A from the left hand side, it becomes A plus B. Now if you pull B from the left hand side from these two strings, it becomes A plus B. Now pull A plus B from the right hand side, it becomes A plus B, A plus B. You can write like this. So in general what it is saying, we have two places, and in first place either A can come or B can come. In the second place either A can come or B can come. So it is regular expression for length 2. Okay, for all the strings of length 2. Let's suppose we want the regular expression for length 3. It becomes A plus B, A plus B, and then A plus B. Okay, we have length 3. Either A can come or B can come, either A can come or B can come, either A can come or B can come. We put concatenation of this. Okay, string of length 4, put one more A plus B. Got it? Or you can, what you can do is find out the language present in it, okay, and then put union into in betweens. That becomes also the regular expression for it. Let's suppose, see one more example. Regular expression for at least two. At least two means, see, what are the language present in it? A, 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 B, B, A, B, B, A, and so on. So the language is infinite. I should at we have to draw the regular expression for the language in which all the strings are of length at least 2 or greater than 2. Okay, so it includes at least 2 means uh, the length of the string can be either 2, either 3 or 4 and so on, but it should at least be 2. Got it? So what we can say, A plus B, on the first place we can have either A or B, and the second place we have can have either A or B. See, it is the regular expression for string of length 2. We have already seen it, right? Now this is exactly 2. I want exactly 2 or greater than 2, means and greater than 2 or greater than 2. So what I'll do, A plus B whole star. Are you getting? See, in place of a star, if I put 0, it overall it becomes a string of length 2. If I put 1 here, overall it becomes a string of length 3. You getting? If I put in place of a star, if I put 2, what it will become? It will become a string of length 4. If I put 3, it will become a string of length 5 and so on. So this is the regular expression for uh, the language containing all the strings with length at least 2. Got it? So let's see one more example. Let's draw the regular expression for at most 2. It means I want the string length in the language to be at most 2. It means either epsilon will be there, 0 length string, or 1 length string, or 2 length string. Got it? So what will be the language present in it? 0 length string is should be accepted, or 1 length string can be there, or 2 length string can be there. A B, B A, or B B. Got it? So by this we know that the language is finite. So if the language is finite, just put union in between and this becomes the regular expression. But it will not look good and it will take time. So what you can do is, mm, see what regular for this language, what you can do, just put the union in between. Sorry, A plus B plus A plus AB plus BA plus BB. If you put like this, sorry, these braces will not come, it becomes in the language. So this is the regular expression for this language. Or you can simply write A. If you simplify it, you can come with this result, what I am writing, what I am going to write. At the first place, either A can come or B can come, or epsilon can also come. Got it? On the second place, either A can come or B can come, or epsilon can also come. See, if I want a string of length 0, how we can derive from it? From both, I can take epsilon. It becomes string of length 0. Okay, epsilon concatenated with epsilon itself is epsilon. Okay, if I want to derive a string of length 1 from this, string of length 1, I can take epsilon from here, I can take A or B from here, or I can take A or B from this side, or and I can take epsilon from it. The overall becomes string of length 1. For a string of length 2, on the same grounds, we can do it. So this is the regular expression for RE. This is the regular expression for at most 2. Got it? So now let's see. Mm, yes. So now let's see regular expression for regular expression if the language is even length. What it means, either 0 length string, either or 2 or 4 length string can be present, or 6 length string can be present, or 8 length can be present, or 10, and so on. So the language is like this. Either you will be having a 0 length string, that is epsilon, or 2 length strings, or 4 length strings. So basically this is the language for which we have to draw the regular expression. Okay, so let's see the language. What I told you, either 0 length string can be there, or 2 length string can be there, and so on. So the language is infinite. Okay, so see, what you could do is a plus b, a plus b, this becomes what? String of length exactly 2. Okay, this is the regular expression for a string of length exactly 2. Are you getting? This is the regular expression for a string of length exactly 2. Why? At the first place, either A can come or B can come. At the second place, either A can come or B can come. String of length 1 can come here, string of length 1 can come here. So it becomes overall concatenation applied in between. So it becomes overall string of length exactly 2. Got it? So now we have to draw for even length. Somehow, see, what can I do? Please check it. If I put a star at uh, whole as a whole and I put star on it, what it becomes? When I put 0 here, overall becomes 0, and it overall becomes as the epsilon. String of length is 0 with the help of with the help of this or a comma b. Okay, so it becomes epsilon. If I put 1 here, so it becomes a string of length exactly 2. Are you getting this? If I put 2 here, what it becomes? It becomes like this. See, if I generalize it or if I expand it, when I put 2 here, it becomes like this. Okay, so it becomes a string of length 4. Now if I put 3 here, it becomes like this, string of length 6. So therefore we are able to find the length of the strings, what, even. Okay, so therefore this is the overall regular expression where the language is of even length. Are you getting? For with whole we applied star here. Now for suppose I have to draw for odd length. We want the regular expression for odd length. How we are going to do it? Let's see. Odd means uh, starting from, it will start from 1, 1, 3, 5, 7, and so on. So how can we draw it? See, right now you will be having some sort of intuition how you are going to approach it. See, if I write a plus b whole star, it is what? String of length 0, 2, 4, 6, everything will come here. Even length strings are coming here. If I simply concatenate with one more AB, what it becomes? See, check it. If I put in place of a star, if I put 1, it becomes overall. It becomes see, this part becomes this part will become epsilon, and this is a plus b comes, so it becomes string of length 1. If I put 1 here, so it becomes string of length 3. If I put 2 here, it becomes string of length, see, if I put 2 here, what it will become? String of length 5. See, when we put 2 here, it eh, on expansion it becomes like this, string of length exactly 4. Are you getting? And we have already one more a plus b, so it becomes a string of length 5, and so on. So this is the regular expression. What? So this is the regular expression, plus b a plus b whole star a plus b. And one more thing, you can concatenate this a plus b in starting also. There is no problem in it. Okay. Let's suppose I want now. Do one more example. Mm, set of all strings uh, set of all strings whose length is divisible by 3. You have to do this. Can you do it? So the language will be string of length 0, string of length 3, string of length 6, string of length 9, string of length 12, and so on. Are you getting? So now you would have developed some sort of intuition how you can draw the regular expression. So see whether it is right or wrong. Let's do it. I can write, see, one more thing, sigma is always a plus b, I'm considering, sorry, a comma b I'm considering. Okay, so we can write a plus b, a plus b, a plus b. If I put whole star to it, what it becomes? Put 0 here, it becomes a string of length 0. Put 1 here, it becomes a string of length 3. Put 2 here, what it becomes? A string of length 6. Put 3 here, what it becomes? String of length 9. So this solved our purpose, what we were uh, wanted to do. Okay, so this is the regular expression for it. Let's do one more example. Hmm. Mm, let's do, okay, then we'll do it in other video. Okay, thank you.